numbers of advantage by using steel as a part of the construction material. Of course, number one is when we talk about the strength. So among the construction material in the world, steel can be considered as one of the strong material for the construction. So by using the steel with this property, so it can give advantage similar as what we discussed before. We can do such a long span design that could be beneficial for a lot of the design capabilities. And then point number two is uniformity. So this is the properties that allow steel to remain their original characteristic from time to times, or in simple word, the properties of the steel that does not change over the times. Okay, so the next advantage is elasticity. So elasticity is the ability of the one material to change back into its original state under high stress or force. So steel does have this kind of properties, so it gives advantage for the structural capability. So while at the same time, the initial value of steel can be accurately calculated compared to another construction material. And then the next advantage is permanence, which is the steel frame with proper maintenance can be last indefinitely over the time. And then the next advantage is ductility, which this is the ability of one material to withstand the extensive deformation under high tensile stress. And then among the material, steel have the higher degree of ductility, which the steel will elongated instead of fracture when there are high tensile stress applied to the steel. And then with this kind of properties is preventing the premature failure to this to the material, which is to the steel. And then the next advantage is toughness. This is the property of the strength and ductility that steel have, allow steel to support large force of loads and allow the steel to be bent without fracture failure. And then on top of that, you can do the addition to existing steel structure, which is the new members of structure easily added to the existing structure, or we can call that as some sort of the modular design. And then of course by using steel, there will be a speed of erection because this is the because of the ability of the steel to be fastened together by multiple way of connection with proper construction plan. And then the last advantage is reusable capability, because components of the steel structure can be easily dismantled and can be reused back in another construction. And then on top of that, the scrap metal or steel can be do for the recycle to form the new steel. And then contrary for the disadvantage, of course when we think about steel, there will be the corrosion. Okay, the corrosion could be one of the main disadvantage of the steel, because when it's exposed to the air and water, it will be easily be corrode. So it's had to be painted periodically, but actually there are type of the steel that have the anti-corrosion ability. outside there. Okay, and then another disadvantage is fireproofing costs. Although structural member are incombustible, their strength significantly decrease exponentially with temperature. So this is yes, we know that the steel is incombustible, but if you if you still remember that the WTC US tragedy, that how that tower collapsed to the ground because of the higher temperature uh, of fire that burned inside the buildings. So of course, when you use the steel as a main structure material for your buildings, so there will be a lot of the fireproofing aspect that have to be considered. And then another disadvantage is fatigue. When this has happened when the strength of the steel reduced due to subjected large number of stress reversal or the variation tensile stress. Uh, and then the last advantage is brittle fracture, which is happen when steel lose its ductility property, and then brittle fracture occur on place of stress concentration. Okay, so as you can see in the diagram in this picture here, uh, so this is the steel, and then for number A, for the first year, so this is what happened when the brittle fracture happened. So when the steel don't have the ductility ability, so and then when you apply the tensile stress force, so it will be fracture, and then it will be failure. So this is in this image you can see this is when steel had the ductility, so it start to become longer. So but to the end it still fail because it's fracture. So this is what we can call as a ductile fracture. uh, so this is the image number C here. So this is what happened when it cannot bear the force of the tensile stress. So it's considered as a completely ductile fracture. So the ductility ability is when they apply the tensile stress force. So from maybe for example from the 10 centimeter diameter, so the steel can be elongated into the smaller diameter. So that's the ductility ability. Okay, and then we move to the material steel, which is, this is the last part, last section, final section for this session. Okay, the steel is start with the integration or the mix of basic metal or iron components, and then it's integrated with the carbon. So carbon content is a crucial determinant of the properties of any iron-based metal. Too much carbon make the steel hard, but it will be brittle metal, like brittle failure, fracture that I explained before. And then while too little carbon produce a malleable, relatively weak material like wrought iron. So for cast iron, so the percentage of the carbon is around less than 3 to 4%, while for steel, the percentage of the carbon is less than 2%. So that's come with the type of the steel alloy, cast steel, cold work steel. So cold work steel is a steel formed into intended shape in the cold state or in the room temperature. So it causes the steel to gain considerable strength through a realignment of its crystalline structure. And then in between steel, there are various types based on their carbon composition. For example, the first one is low carbon steel, which is the percentage of the carbon is around 0.04% to 0.3%, or we can call that as a mild steel. This is the type of the steel that mainly used in the structural building component. It does have the low carbon with additional elements such as manganese, silicon, aluminium, and etc. The second type is medium carbon steel, which is the percentage of the carbon is in between 0.31% to 0.6% carbon. It's stronger, and then but it will be difficult to weld, and then it will be difficult to form and cut this kind of steel. And then the last one is the high carbon steel, which does have the percentage of carbon in between 0.61% to 1.65%. So this is the extremely hard steel, and then it does have the brittle fracture capability. And then the last one is the wrought iron, which have the amount, the percentage of carbon less than 0.08%.